Hello, today I'm going to be going through how to find probabilities in a probability density function. So just for a bit of background knowledge, when we do things like flip a coin, we're dealing with what's called a discrete random variable. So the thing with these is that there are a finite number of outcomes. Taking that previous example, you can only get heads or tails. What we're going to be working with instead today is what's called a continuous random variable. So these are things like temperature, height, weight, and what's different about these is that you essentially have an infinite number of outcomes. Because if you were to measure someone's height, technically you could measure it to an infinite number of decimal places, and hence you would have an infinite number of outcomes. So we have to deal with these in a different way, and namely it's using a probability density function. So these are normally defined between two values, and it's just a function. And the way we define probability is that it's the area underneath the curve. So say I wanted to find the probability of a value m. Well, taking that definition, the area underneath the curve of like just this line is going to be 0, like there is no area. So the probability of getting a specific value m is going to be 0. And this is the case with any value. If you just want the probability of a specific value, it's always going to be 0. So how can we think about this logically? Well, say you wanted to measure the temperature of a bucket of water, and you wanted to find the probability that it's going to be 35 degrees Celsius. If you rounded it off to the nearest degree, then like there's a decent chance that you'll get exactly 35 degrees. But say you wanted to measure it to 2 decimal places. Well, there are 100 times as many outcomes, and hence your probability of getting exactly 35 degrees is going to drop. If you measure it to 10 decimal places, there are even more outcomes, and hence the probability will drop even further. Now, if we as with continuous random variables, we're essentially measuring it to an infinite number of decimal places, and the probability that you'll get exactly 35 degrees is going to get so infinitesimally small that we can essentially treat it as 0. So instead, what we work with is what's called a range of values. So m and n. We work with, okay, what's the probability that I'll get a value between m and n? This time, there is an area underneath the curve. It's that area there, and that will give us, actually give us a probability. So how would we find this area? Well, we need to draw on what we know from calculus, and we need to integrate the function between m and n. So I think the best way to do this is to jump straight into a question. So the question says, a group of students studying at the library are surveyed and the weight of their bags are represented by the probability density function fx is equal to 3 on 125x squared from 0 to 5. If a student is chosen at random, what is the probability that their bag will be part A, 3 kilograms or lighter? So let's do that. So in this case, we're kind of assuming that there are like so many students that we can't like account for the probabilities in a discrete way. So we'll just take that as fact. And then the first thing I'm going to do is just draw this probability density function. This isn't necessary to figure it out, but I think it's a good way to explain what's happening. So we're trying to find the probability that it will be 3 kilograms or lighter. So p x, our random variable, is going to be less than or equal to 3. Then what we're trying to find is this area here. That we're trying to find the area underneath the curve from 0 to 3. So the way we do that is by integrating. 125x squared dx. When I integrate that, it becomes x cubed, and I divide by 3, so that's 125. 3 cubed is 27 on 125. So this is the probability that the weight of the bag that I randomly choose is going to be 27 on, is going to be less than 3 kilograms. It's going to be 27 on 125. Now part B. what's the probability that it will be lighter than 3 kilograms? So Px less than 3. Well, the interesting thing about this is that this is going to be exactly the same as our answer in part A because of what we were talking about before. The probability of getting a specific value is going to be 0. So it actually doesn't matter if we have this less than or equal to, or if we just have the less than. It's still going to be the same answer. So that's part 2 done as well. Let's move on to part C. So it says, what's the probability that it will be between 3.5 kilograms and 4.6 kilograms? So this time I've got to rub this out. And I'm trying to find between 3.5 and 4.6. So I'm trying to find this area here. So we can do that in a very similar way. Again, it doesn't really matter if we have the less than or equal to sign or if it's just the less than sign. So I'm integrating between 3.5 and 4.6 because that's where we want the area underneath the curve. 3 on 125 x cubed or x squared dx. The 3 is going to cancel out again, so 125, 4.6, 3.5. And now, if I sub that in, 4.6 cubed on 125, take away 3.5 cubed on 125, I get 0.43568. And that's the probability that the bag that I randomly pick is going to be between 3.5 kilos and 4.6 kilos. And that's it for this video.